Hello everyone and welcome to TC World Conference 2020, our second World Conference. My name is Marte Schlösser. I'm your moderator today. I'm a student of Communication and Media Management in Karlsruhe. And this session will be about charming the word snake, terminology at work and language checking with Python. It's presented by Maximilian Rosin and Esther Strauch. A few words for organization. If you have any technical issues, please feel free to submit them in the question corner. The same goes for any questions during the presentation. And there is a special feature in this session. Henk, our graphic recorder, is in our midst. After the presentation, Henk will share his screen and his graphics about this session. And now I would like to pass the word to our speaker. It's great to have you here today.
Thank you very much and welcome to our tutorial. So welcome to our tutorial, Charming the Word Snake, Terminology Work and Language Checking with Python. My name is Esther Strauch. I've been working as a technical communicator for Parson since 2014. And I am the terminologist and the linguist in this interdisciplinary project. My colleague, Maximilian Rosin, he works as a technical consultant and provides the programmer's perspective in this tutorial. We work at Parson. We are service providers for technical documentation, consulting, and development. Our offices are located in Hamburg and Berlin. And if you'd like to know more about our services, you can find information on our website. As for the agenda, after a very short introduction, there are two main segments of our tutorial, namely the terminology extraction and the checking of writing rules. And at the end, we will have some time for an outlook and a discussion, and of course, the graphic recording at the end. So what will we cover with our tutorial? What's the idea behind? Well, first, that it's possible to implement powerful tools in just a few days using only free open source software. Second, we want to show you how to find a starting point for terminology work, a first list as a basis for further discussions, for example, in a terminology circle. And last but not least, it's helpful to start with a specific research question. As the time of our tutorial is limited, of course, we cannot cover all subjects that we would like to cover, but these are for us the main points. So let's start with some necessary theory of terminology. In this tutorial, we will mention concepts and terms. They are both connected with objects. So when we speak about an object, what we mean is any material or immaterial matter, event, or circumstance. With concept, we mean notion or idea that represents the object in one's mind. And with term, we mean language-specific code that represents a concept. It's important to make this distinction because one term could, for example, belong to multiple concepts. For example, the concept of mouse as an animal or mouse that you use when you work at a computer. Also, one object could be represented by multiple terms. And this slide shows a useful segmentation of a terminology project into phases. Usually, phase one would include identifying the key colleagues for the terminology project. That could be colleagues from the product management, technical specialists, or from quality control, and of course, selecting the right tools. And what we will cover with our tutorial is phase two in the terminology project and also the beginning of phase three. What we found charming is the idea to get a first draft of a terminology list without investing much time in the planning before. the extraction, and then after the extraction, continuing with the planning with more knowledge about the terminology issues or the technical questions. But nevertheless, our final goal is getting a complete terminology list with allowed and forbidden terms. Such a terminology list is usually divided into two levels, the term level and the concept level. And the work starts at the term level. Here I have marked with a red color in which categories our do-it-yourself approach can support you. On term level, automatic term extraction can lead to a first list of terms, including information like the part of speech and even context information. An important further step is defining the concept in order to discuss, for example, in a terminology circle, which terms will be considered as allowed or forbidden or deprecated. Finding definitions in open source dictionaries can save time and provide a basis for discussions. There are other categories that we did not put a focus on, but kind of language and source are categories that you either know before or you can find them out easily. So we did not put a focus on, but as I said here, with the red color, you see the categories where an automatic term extraction can help you. This is an example how a terminology list in Excel could look like. So you have one column per data category. You define allowed values, you use formatting like colors for the status, and you separate concepts with different ID numbers. So far for the theory, and now my colleague will show you the practical part using Jupyter Notebook, showing the term extraction. Thank you.
So hi from me, I'm Maximilian. I'm the programmer in this little project, and we are now going to switch from PowerPoint to a Jupyter Notebook. Just a little quick note before, this is not the tool. This Jupyter Notebook is just a presentation device that allows me to show you code and execute it in a somewhat presentable environment. So our goal, as Esther mentioned, is that we want to build a list of one-word terms surrounding the COVID-19 pandemic. And we're going to use the Wikipedia article on the COVID-19 pandemic as our source text. Or to be more precise, we're going to use the first paragraph. As I mentioned, for simplicity's sake, we're going to limit ourselves to one-word terms, but this will, I believe, suffice to actually demonstrate the capabilities of natural language processing. We are going to use Python as the programming language, mainly for three reasons. First of all, Python puts a lot of focus on readability, while still being a fully capable programming language. So it's pretty accessible for beginners while still providing everything you need. Second of all, it is an interpreted language, which basically means you can simply write scripts and execute them without worrying too much about compilers and stuff. And the third, and I guess it's the most compelling reason, is that there are a gazillion libraries available for Python that solve almost any common task. So you need to parse HTML, there's a library for that. You want to write CSV, so there's a library for that. And some of those libraries you will encounter in this talk. So let's go down into the text. So you can see here, this is the first paragraph of the Wikipedia article on the COVID-19 pandemic. So the first thing we are going to do is we're going to read that text as a simple string into memory and convert it to lowercase. we do the last thing, we convert it to lowercase to save us a lot of headache along the way. And it's quite a common thing when you're working with natural language in programming environments. The next step is the first library you will encounter for today. It's the Spatie library. This is basically the natural language processing tool. And by importing that library, and you see it takes quite a moment, we make all the powerful natural language processing commands that Spatie provides available to our program. The next line looks rather unsuspicious, but it actually, and you can see it once again, takes a while to execute. This little line contains most of the magic that Spatie provides. What just happened is that we loaded a full model of the English language, and we can use this model that has been trained on a very, very large corpus to extract all the features from our text. Finally, we are going to feed the text into the model, as you can see here, and this returns a document object which basically already contains all the features we will need to extract the terminology and add the metadata. Don't worry too much about this little function here, it just helps me to pretty print the results so they are more readable for you. So before we continue, we need to do a little bit of theory. We need to define three important concepts that we are going to use. The first one is token. A token is, simply said, a little segment of a sentence. Most of the time it's a word, sometimes it could also be a punctuation mark. The lemma is the base form of a token. For example, if the token is a verb like has, the lemma would be have. The part of speech is a tag that we can assign to a token that tells us what kind of word we're dealing with here. But I want to demonstrate that for you. For example, we take this sample sentence, the dog has a wet nose. What we're doing here is we're going to feed that sentence into our language model, and then we're going to look at these three different concepts. So what you can see here, this is the sentence in a tokenized form. In the next column, you see the lemma, and as I said before, for example, has and the lemma is have. And the part of speech tag, for example, nose is obviously a noun, or for example, have is an auxiliary verb. So this is basically all we need to continue. So we can now start to build this list of one-word terms. To filter all the words that we can find in our list for relevant terms, we're going to make a very, very simple assumption. The only terms we're interested in are nouns, proper nouns, and verbs. The reasoning behind this is quite simple. Nouns and proper nouns usually correspond to objects the objects that we're talking about, but while verbs usually refer to activities we're talking about. And I guess it's sort of obvious that these two things are very, very relevant when in the domain of technical communication. So we define our little function that we can pass a token into, and that then tells us whether this token is a relevant term or not. And all we have to do now is just go through every token in our first paragraph in our document, decide whether it is relevant or not, and if it is, we append the lemma of that token and the part of speech tag to our list. We use the lemma because in a terminology list, we only care about the base form, and we add the post tag because sometimes in the English language, it is not enough to just have the term to decide whether it's a verb or a noun. For example, attribute. You cannot really tell whether it's to attribute or the attribute. So we need the post tag. We do that. Now, as you all know, there may be some duplicates. We just remove them in the next step. And well, let's have a look at what we've got so far. So these are all the terms that fit our requirement for relevancy and the pos tag that we can find in the first paragraph of this Wikipedia article. If you look closely, you can already see something peculiar. For example, although we removed all the duplicates, coronavirus appears twice, once as a noun and once as a proper noun. This is a hint that the latter, coronavirus as a proper noun, is actually part of a two-word term. In this case, I suspect coronavirus pandemic. But pretty impressive for just a few lines of code, I think. So as I mentioned before, that it would be nice to have some context for terms. And the most obvious idea would be to take a term and look for a sentence that contains this term in the original document. And Spacy can help us with that too. Spacy has the so-called sentenizer that we can use to basically iterate through all the sentences in a given document. I will just demonstrate that to you. Not sure how well you can see that, but what has happened here is basically we have separated the text into individual sentences. So what we can do next is we could create a list of all the sentences, including the lemmas they contain. This is a little bit sort of a bigger chunk of code now, but if we print out what we've got so far, you can see that, for example, this is the first sentence, and here is the list of all the terms and the corresponding part of speech tags. And we can use this data structure now to go through every term in our term list, then we'll go through all the sentences and look up which sentence contains that term. So we're done, and let's look at the results again. So for example, here we have the term attribute, the pos tag verb, and here we have the sample sentences, and you can see the verb attribute is here used as a participle, I guess, or well, maybe it's simple past. It's just simple past, yes. But you can see we added now, we have a sample sentence for every single term in our term list. That's already great, but now let's leave the term level and transition to the concept level. Definitions would be really, really helpful if we could add them. But obviously the problem is we cannot extract those definitions from the text. We need some third-party source here. In our case, we're going to use the free word set dictionary, which is basically a dictionary, a large dictionary in JSON format. But you could use any other source as long as it's programmatically accessible. The words to look out for are REST API, structured data, something like that. So once again, a rather big block of code. Don't worry too much about this. Most of the code deals with the case when we cannot find the word or the word in the dictionary. So let's execute this. This takes a little moment. You can see some of the terms we cannot find in the dictionary. And well, let's look at the results again. So for example, again, the term attribute, and here we have the definition from the dictionary to attribute or credit to. But once again, something peculiar happened, and I want to show this to you, which sort of neatly demonstrates the difference between term and concept. For example, we have the term China, and we know that this refers to the country. However, in our dictionary, we found the following definition: high quality porcelain. This is basically just this is the problem with synonyms that we have. So the computer cannot do the thinking for you. The moment we transition to the meaning level, this is where humans are required and where your personal expertise is necessary. So, okay. The last thing we want to do is, of course, you do not want to do all the analysis and discussion in Python. You want to write that to a file, and we're going to write this to a CSV file. It's rather easy with the inbuilt libraries, and I want to show that to you how this looks, because now we can simply import that. I've already opened that. We can import that, for example, into Excel. And it takes a moment. I hope this is the right button. And you see what we got here is basically a very, very first term list that we can use for further discussion. So this concludes the first demo. There's some further ideas about what we could do. We could try to count the frequency of terms. We could obviously add two-word terms to the list. Although this is a little bit tougher than it sounds, it would, put it simply, include searching for all the bigrams and then calculating whether those two words appear together very frequently compared to the frequency of the individual terms. Unfortunately, Spacy does not provide any inbuilt functionality for that, so we would have to do that ourselves. A more out there idea would be to actually try to evaluate relationships between terms by looking for something that we call collocation. So, for example, we could try to count how often each term appears together with each other term in the same sentence. This would give us an idea of which ideas and terms are related. So with that, I want to give it back to Esther to continue with the presentation.
So thank you very much, Max. So to conclude the first part, what we did, we started with the preparation of our text, which was the basis for the extraction of one-word terms and part of speech tags. We then added context sentences because they can be helpful in the terminology work ahead. On concept level, we were able to find definitions or propositions for them more easily in open source dictionaries. And as our goal is a complete terminology list, we use the output as a basis for the further terminology work, which is defining the concepts, discussing allowed and forbidden status of terms, and so on. So now I think we have time for at least one question. Are there already questions from the audience? So there are no questions from the audience yet. Then we can continue with the next part. So what's the use of the terminology list? We want to use it to improve the text quality. And I think we all know examples for bad text quality that could be that the sentences are too long, or the structure is too complex or too complicated because of the use of subordinate clauses, and you could use terms that are considered as not allowed. And how we could use, for example, a terminology list to improve the text quality, that will be shown to you by my colleague Max now. Thank you.
So thank you again. Back to Jupyter Notebook and the second part. Let me just make it this full screen. So we want to implement some writing rules. The first thing that we need is some sort of sample text, and we are going to use this rather gruesome German sample text. There are two reasons for why we're using German now. First of all, I just wanted to show you that Spacy is basically capable of dealing with other languages, but also implementing writing rules may require some intimate knowledge of the language, and just know German better than English. So, but the overall procedure in the beginning is the same. We load the text into memory, then we load a language model, this time, of course, a German one. And we wait a second until it's loaded. It takes, and we're done. And now we feed the text into the model. So as Esther mentioned before, the most obvious use case would be looking for forbidden words, putting the terminology we just extracted to use. So what we need is, first of all, we need a list of forbidden words. I just prepared one. And now finding forbidden words is really, really simple with space. And if you ever try to do that in, say, words by using search and replace, you know that the hardest part is getting all those flexions and all these alternative forms that a word can take, especially if it's irregular. With Spacy, this is really, really easy because maybe you remember we had this lemma method which returns the base form of a word. So all we need to do is go through every token in our document, check whether the lemma corresponds to a forbidden word in our list, and then print that out, maybe plus some context. And so, for example, in our case, we found all 3 words in our text, and you can see here, these are the sample sentences. To see the lemma method in action, for example, we had the verb erfolgen, and you see here, this is not the base form, but rather one of many forms. When talking about words, a major source of comprehension problems are long words. And you can find different ideas what makes up a long word. In German, it would not be so helpful to count characters because we have a lot of constructs that use many characters for producing very short syllables. So the better idea would be to count syllables. However, counting syllables is not easy. We can, although, think of a very, very simple heuristic that can help us. If we examine the German language closely, we can see that almost every syllable contains at least one vowel. So the first idea we could have is we just count vowels and use that as an estimate. Looking a little bit more closely, we realize a lot of times there are words that have 2 vowels next to each other, what we could call diphthongs. So if we know all the vowels and we know all the diphthongs, we could count them, and the difference between them gives us a surprisingly good estimation for the number of syllables in a word. So this is basically what we define here. And what we now do is, again, we just go through every single token in our text and check whether it fits the requirement of being a long word. For example, it has more than 3 syllables or more than 10 characters, and then we just print that out. So let's see what we've got here. Well, this is a monster. 20 syllables, 63 characters. And for those who do not know, this is actually the name of a law that is in effect in Germany, as far as I know. That is not nice. But not only words can be long, sentences can be long too. And there are at least 3 reasons why we should avoid long sentences. First of all, they are hard to read and understand. Second of all, if the sentences get too long, grammatic reference can become ambiguous. And third, the longer the sentence, the easier it is to make mistakes. So if you're scanning the literature, you find different limits for what makes a sentence long, usually based on word count. For the purpose of this talk, I just assume a sentence is long if it contains more than 15 words. And once again, using Spacy's Sentenizer, this is very, very easy. So we found 2 long sentences in the sample text. I guess it's the first sentence with 34 words and another sentence with at least 17 words. There are more things we could do at sentence level, a surprisingly interesting research question is that counting commas can be very revealing. If a sentence basically simply contains more than one comma, this is usually a hint at optimization potential. And let's just do that and see what we can find. For example, here a sentence with 2 commas, and we have a dependent clause inserted in the middle. Or for example, here we have a sentence with 3 commas. This sentence, for example, should better be turned into a list. Another common issue are nominalizations. While they're not wrong per se, they can make a text static, bureaucratic, and passive. However, it is not that easy to actually identify all nominalizations. Some of them are very hidden in German. But we still can use a simple heuristic to find the worst offenders, at least. And heuristic is rather simple. We just look at a word, and if it is a noun and ends on one of those 4 syllables, Keit, Heit, or Zion, then we can be pretty sure that we're dealing with a nominalization. So for the purpose of this discussion, let's just run this little function. And now check every single sentence, see what we find. Oh, this is one sentence which actually contains 3 nominalizations. And this sentence is bureaucratic and static indeed. And with this, the second demonstration is finished. I just want to leave you with some further ideas what we could do. For example, we could try to find passive sentences. This could be very easy. We just need to look for auxiliary verbs and participles occurring together in one sentence. We could try checking for the erroneous use of das with double S versus das, although this could prove harder than it sounds. And apart from checking writing rules, we could also see or try to estimate the results, the increase in readability, by calculating readability indices using basically the same functions, or we could try to estimate the reading time. And with this, I am done for the moment, and I give it back to Esther to wrap up the talk.
So thank you very much. To summarize, so to summarize this part, first we prepared the source, then we used the terminology list that we have created before to find the forbidden or deprecated terms. We identified words or sentences that we found too long by counting the syllables or words respectively. And we could even find nominalizations with the help of part of speech tags and suffixes. So now I think we have time for outlook and discussion. First, I would like to show you the references that we use for this tutorial. I think that could be helpful if you want to learn more about Python. And this will be also part of the handout that we will give to you for this tutorial. Here you see our contact data. We are, of course, like to be available for you for questions afterwards. And we would like to be grateful if you could rate our tutorial today. So now before we finish with the graphic recording, we have time for a few questions.
Yeah, and there are some questions. Thank you. At first, thank you very much for this very interesting presentation. Yeah. First question. There was a lot of question. If you could you provide your code in some way? it is possible?
I think that's a good question for my colleague Max. Would you like to answer this question?
Yes. It's strange with switching around all the time. I try to upload that to the what do you call it in English? The Tagungstool. What is it called in? But it only accepts PDF, so it should be in a PDF format. It's in the handout, but I'm not sure. I'm trying to figure something out to share that. I guess there's no problem with doing that. Just have to figure out a way to do that. Maybe I will post in the event app. I'm trying to think of something.
Perfect. A lot of people ask this. But there are other questions. What are good resources to learn Python?
I just want to skip back a moment. If you buy one book or read one book, I would recommend Al Zweigert's Automate the Boring Stuff. I guess it's also available for free online, but there is a new edition out a couple of days ago. So check out the website, check out the book. I would recommend this is the book to read if you're in an office environment and just want to automate some stuff with Python and get a first idea of it.
All right. Then there's a question. Could you please explain again what feeding the text into the model means?
So basically, it's a good question. It's not that easy. First of all, try to show the code again, what we are doing, or what I did because basically it's this little line of code. You can see what we're here doing is NLP. This variable contains the model, the language model, and this variable contains a text. And all we actually do what I did as a programmer, I basically took the text and put it into the model. There's not much more. Behind the scenes, there's a lot of things happening. Basically, Spacey is trying to extract. It's basically a full-blown pipeline. I cannot show that now. There's basically a huge pipeline that includes tokenizing, extracting features, and so on and so forth. That happens in the background, and you don't see it as a programmer. If you want to learn more about that, I would recommend the excellent documentation of Spacey. That is spacey.io. I guess it's also listed in the references. It contains a very detailed explanation of the pipeline.
All right, thank you very much. Then there's a question, what kind of criteria does a text have to meet that it can be processed with Python?
So we're basically a little bit skipped over that. Basically all sorts of text. I mean, you need a model, a language model. If you want to use Spacey, you should pay attention to encoding issues, especially if the stuff is in, for example, non-Western languages, or if you're dealing with languages that have complex or unusual symbols, like, for example, German has those umlauts, or Scandinavian languages. So encoding can be an issue. But basically all you have to do is somehow get that text into a string, which is hard. This may be just the most tedious part of actually getting your text into the program. And this could be a whole talk of itself. But basically any text, as long as you have a model and you can somewhat turn it into UTF-8 encoded strings, then fine, you can do that.
All right. Could you explain how you would estimate reading time?
I think I can give you a very simple answer. I would just count words. For example, in the preparation of this talk, I just wrote it up with a little script, and I know that my talking speed is something like 110 words per minute. So, and there's list of reading speeds. You can, I guess, even on Wikipedia, you can look that up, and you just count words and calculate the speed. Of course, you can do it more complicated. This is obviously.
I cannot hear. Do you hear me?
Yes, we can hear you. It seems that Marte has some technical problems, so I will take over the questions. Just a second. Okay, so we have another question. Are there open source terminology extraction tools where I do not have to do programming myself?
I would actually give that question to Esther. Is some right? Is that correct? Mike? You know some open source terminology extraction tools? I hand it over.
Yeah, that's a good question. I think I would share them. I know some. I do not use them regularly, but I think there are some, and I would like to share them in the chat after the tutorial, so that you have a specific address. Thank you.
Mhm. Thank you. Another question. Any other writing rules you would recommend for English?
Oh, it's a good question. There are so many. Well, I would definitely recommend to not start with too many, because that can be tedious. But I often work with rules like do not use sentences that are too long, which is, well, not easy to correct, but that's a mistake, I'd say, that happens often. Yeah, sentences that are too complex. So try to use the active voice and limit the words of a sentence. Yeah, use the terminology list to eliminate the forbidden or deprecated terms. That's already a lot. Yeah, and there are many. Yeah, many rules that you could use. I also recommend the documents that the TCOM has published as for the writing rules, because that's a good reference. We will share the titles in the chat also, because that's a good reference for the rules available.
Perfect. Thank you very much. And we are out of time for more questions, but there are some left in our questions section. So I would like to encourage you all to go to chat in the app, in the event app, and there you can continue the conversation with our speakers. I would like to now give screen to Henk to show us his graphic recording.
Mm-hmm.
Hello. Can you see the screen or?
Yes, we can. Perfect.
Great. So it's I made a little bit of joke out of it because the snake and the mouse were triggering me, and it fits because the snake has a word and has a picture, and the mouse can have different meanings. So that's connected to the triangle object concept and term, and also the fact that standardization is important. Today, you talked about Python as a tool, which is very accessible, simple to write scripts, and has a gazillion library for recurring tasks. So that makes it easy to work with and quickly to implement, as I understood. I described phase 2 extraction, the steps that are necessary in the program, which were very nice, shown with examples on the fly by Maximilian. And yeah, one of the things I remember was that use terminology to improve the text quality, and too much commas are a potential for optimization. So, and again, the process of the writing rules to optimize your text. It's not finished yet, but hope it gives a good representation of the talk.
Great.
Thank you.
It looks amazing, like all the other recordings that you've done. I hope you all like it. And we are at the end of our session. I would like to thank all our attendees for joining us, and a special thanks to our speakers for sharing their knowledge and experience with us. I would like to invite all of you to still join us in the other sessions this afternoon, the last afternoon of our TC World Conference this year. And from our side, that would be it. Have a nice rest of the day, and goodbye.
Thank you. Goodbye.